Good day, everyone. Reporting first from Group 2, I am Yulex Ariadne Salipsip. We're going to report about the chemistry of air. So first of all, what is air? Air is the invisible mixture of gases that surrounds the Earth. Air contains important substances such as oxygen and nitrogen that most species need to survive. We have here the different compositions of dry air. So dry air is made up of nitrogen, oxygen, argon, carbon dioxide, neon, helium, krypton, hydrogen, and xenon. As you can see from the periodic table, we can find the different composition of air on the upper right corner of the periodic table. Here are the ones with the light green color. So what is air chemistry, or chemistry of air? Air chemistry can also be called atmospheric chemistry, which is a division of atmospheric science that studies the composition of chemical species that make up the atmosphere. The composition and chemistry of the atmosphere requires critical understanding for many reasons. Most importantly, for defining the interaction between the atmosphere and all living organisms. The Earth's atmosphere has been altered by human activities, mostly from the beginning of the Industrial Revolution to the present day, and some of these changes are harmful to human health, agriculture, and ecosystem. So, here are some numbers of critical environmental issues associated with the changing atmosphere, which are photochemical smog, global climate change, toxic air pollutants, acidic deposition, and stratospheric ozone depletion. Air is everywhere, so we have to keep it fresh, especially we are breathing it. So this is the end of my topic. Once again, Yulex Ariadne Salipsip from Group 2, Chemistry of Air.
Good day, everyone. I'm Marte Hogalang, reporting number 2 from Group 2, Chemistry of the Air, the major gas components and their roles in the atmosphere. Gases. The most abundant naturally occurring gas is nitrogen, which makes up about 78% of air. Oxygen is the second most abundant gas at about 21%. The inert gas argon is the third most abundant gas at 0.93%. There are also trace amounts of carbon dioxide, neon, helium, methane, krypton, hydrogen, nitrous oxide, xenon, ozone, iodine, carbon monoxide, and ammonia in the atmosphere. Water vapor. Due to the water cycle, the amount of water in the air is constantly changing. The lower troposphere can contain up to 4% water vapor in areas near the tropics, while the poles contain only trace amount of water vapor. The concentration of water vapor decreased drastically with altitude. The upper troposphere has considerably less water vapor than air near the surface. The stratosphere and mesosphere have also no water vapor, and the thermosphere contain none at all. Aerosol. Air also contains tiny solid particles called aerosol, such as dust, sea salt, and ash from erupting volcanoes or forest fire. Many of these particles are so small that they are microscopic. Others are large enough to see. Aerosol affect climate by helping clouds form and shading the planet by scattering or absorbing sunlight. In the last century, manufacture and widespread use of combustion engine have increased the number of aerosols in the atmosphere as particulate matters exposed from smokestack and exhaust pipes. Burning wood and other materials also add particles to the air. Nitrogen. 98% of the air in the atmosphere is nitrogen. Nitrogen is transferred to plants, animals, and the environment through the nitrogen cycle. Nitrogen oxide. Nitrogen oxides are air pollutants that contribute to the formation of ozone. They also create nitric acid, which is part of acid rain when they mix with water droplets in the air. Oxygen. Oxygen makes up 21% of the atmosphere. It is highly reactive and it forms compounds with numerous other chemicals and is necessary for respiration in living things. Ozone. Ozone in the troposphere is a human-made pollutant. Ozone is in a stratosphere forms the ozone layer, which is crucial for the survival of life at the Earth's surface. Argon. Argon makes up about 1% of the atmosphere and comes mostly from the decay of potassium in the Earth's crust. It is an inert gas, which means that it does not react with other chemicals. Water vapor. Water vapor is a cycle through all of Earth's system in each of its three phases: solid, liquid, or gas. Water vapor in the atmosphere is a greenhouse gas due to its heat-trapping ability. Carbon dioxide. Carbon dioxide naturally composes about 0.03% of the atmosphere, but the amount is decreasing due to the burning of fossil fuels. Plant and bacteria use carbon dioxide during photosynthesis. Humans, others, animals, and plants add into the air through respiration. Carbon dioxide is a heat-trapping greenhouse gas. Carbon monoxide. Carbon monoxide in the air comes from burning fuel in vehicle volcanoes and forest fires. It is a poisonous gas. Methane. Methane gas is released into the air from landfills, livestock, and their manure and from oil and gas wells. It is also created when organic material decomposes. It is a heat-trapping greenhouse gas. Sulfur oxide. Sulfur oxides are produced when coal and oil are burned. It is also released from volcanoes. The sulfur oxides mix with water droplets in the atmosphere to create sulfuric acid, which is a component of acid rain. That's all. Thank you.
Good day, everyone. I'm Aaron Pabro from Group 2, reporting on air pollutants. So, today we are talking about primary pollutants. What is primary pollutants? Primary pollutants are any type of pollutant directly into the environment. They differ from secondary pollutants because secondary pollutants must form in the atmosphere. Primary pollutants can be emitted from many sources, including cars, coal-fired power plants, natural gas power plants, biomass burning, natural forest fires, volcanoes, and many more. The first type of primary pollutant is the carbon monoxide. Carbon monoxide is dangerous to humans once inhaled. It competes with oxygen by attaching on the hemoglobin in red blood cells and starving vital organs such as brain, nervous system, and the heart of the oxygen, reducing their ability to work properly. The biggest source of carbon monoxide comes from vehicles, especially when they are moving slowly or when the engine is idle. Carbon monoxide is colorless, odorless, and very poisonous gas. The second type of primary pollutant is the nitrogen dioxide. Nitrogen dioxide are a group of gases made of varying amounts of oxygen and nitrogen molecules. Nitrogen dioxide is the most common, which is reddish-brown gas that has an unpleasant smell and it is poisonous in high concentration. Nitrogen dioxide are formed when fossil fuels are burned at high temperatures, but can also be formed naturally by lightning strikes. Nitrogen dioxide increases the likelihood of respiratory problems as it inflames the lining of the lungs. It can reduce immunity to lung infections. This can cause problems such as wheezing, coughing, colds, flu, and bronchitis. The third one is sulfur dioxide. Sulfur dioxide are a group of compounds made of sulfur and oxygen molecules. The most common is sulfur dioxide. It's a colorless gas with a burn match type of smell. They are formed during the burning of fuels containing sulfur, such as coal and oil, and metal containing ores, including aluminum, copper, zinc, lead, and iron. Most of, sul- most of sulfur dioxide in our air is caused by burning of coal and oil for energy generation and industrial activities. It is also produced from natural sources such as active volcanoes and hot springs. Sulfur dioxide can cause breathing difficulties if inhaled into the body. It is also toxic to plants and can cause acid rain when it reacts with moisture in the air. Fourth one is particulates. Particulates or particulate matter are tiny pieces of solid matter or liquids in the air and can consist of 100 different chemicals including carbon, sulfur, nitrogen, and metal compounds. They originate from many different sources, including construction sites, vehicle exhaust, industrial sites, unpaved roads, and come in many shapes and sizes. Some are large enough to be seen with the naked eye, whereas others can only be seen through powerful microscopes. And the last one is ammonia. Ammonia is a very soluble colorless gas with a strong pungent smell. It is primarily released from animal waste and fertilizer use, vehicle exhaust, and other processes. The biggest source of ammonia release is from agriculture, including the intensive rearing of animals and crops. When ammonia and ammonium pollutants fall to the ground, they add to the nitrogen enrichment effects, increasing the growth of some plants, including trees. And that's all. Thank you.
Hi, I am Margie Gonawa and I'll be reporting the secondary pollutants under air pollution. So secondary air pollutants are formed when primary pollutants interact with the atmosphere. So these pollutants are not emitted directly from a source. So those are the primary pollutants from our environment will now interact with the atmosphere and become now the secondary pollutants. Example, the fumes from our exhaust will now mix with the oxygen and produce a nitrogen dioxide, and this is now the secondary air pollutant. Another type of secondary air pollutant is the photochemical smog. So this pollutant is haze in the atmosphere accompanied by high levels of ozone and nitrogen oxide caused by the action of sunlight on pollutants. So usually, this is seen in the urban areas, especially in the morning or evening, wherein most of the residents use their vehicle going to work or going to school. So this means also that there are more smoke produced. The next one is the ozone with the chemical formula of O3. So it is naturally found in the Earth's stratosphere. It helps absorb the ultraviolet radiation from the sun. Ground level ozone, or the bad ozone that form closer to the Earth in the air we breathe. So the volatile organic compounds, those are the chemical usually found in many products we use at home, like from paints, air freshener, cleaning products, and even smoke. And adding with the nitrogen oxide, so those are the poisonous gases from fuel burnt from vehicle or factory, and will now interact with the sunlight and produce the ground level ozone or the bad ozone. The next one is the acid deposition, or also known as the acid rain. So this refers to the many ways in which acidity can move from the atmosphere. So this is a mixture of air pollution that deposit from the atmosphere, and this leads to the acidification of soils and fresh water. So these acidic components will fall to the ground in form of either wet or dry. So those are the primary pollutants from combustion of fossil fuels, and will interact with the clouds, wherein the clouds contains H2O. They will now produce the nitric acid and sulfuric acid, and will now fall down to the ground in form of either rain, snow, fog, hail, or even dust. The next one is the nitrogen dioxide. So this is a toxic reddish-brown gas that is strong oxidizing agent, is produced by combustion or burning of fossil fuels, and is an atmospheric pollutant, or also called the smog. So emission from cars, nitrogen dioxide emission from cars, trucks or buses, power plants, and off-road equipment will now interact with sunlight, and the smog is produced. The next one is the particulate matter, or the PM. Particulate matter is a term used in air pollution to describe the mixture of liquid, droplets, and solid particles present in the air. The size of pollutants varies and may contain different kinds of chemicals and materials. Inhaled particles can cause negative effects on the health. So this is how PM is formulated or formed. So the primary sources might come from construction site, unpaved roads, agriculture operation, or forest fire. They will now interact with the carbon monoxide, sulfur dioxide, or nitrogen oxide, or ammonia, and become the aerosol particles. So those aerosol particles can be extremely small solid particles or very small liquid droplets suspended in the atmosphere. The next one is the peroxyacyl nitrates, or the PANs. So this is a secondary pollutant since they form in the atmosphere after the emission of primary pollutant. Sources of the pollutants required to create PANs include motor vehicle, tobacco smoke, and the burning of fossil fuels. So this is a powerful respiratory and eye irritants present in photochemical smog, and the most serious biological effects of PANs are of phytotoxic nature, resulting in injury to plants and vegetation. The next one is the sulfur trioxide. So those are the produced by the oxidation of sulfur dioxide. Next one is the nitric acid. So this is a colorless, fuming, and highly corrosive liquid that is commonly laboratory reagent for the manufacturing of fertilizer and explosive. So when exposed to human, this can be uh, can cause eye irritation or severe skin burn. So nitric acid is also present to acid rain. Next one is the hydrogen peroxide, an unstable compound used especially as an oxidizing and bleaching agent, an antiseptic, and propellant. Hydrogen peroxide is a colorless liquid at room temperature with a bitter taste. A small amount of gaseous hydrogen peroxide occurs naturally in the air. So, ammonium. It is derived from the ammonia by combination with the hydrogen ion and known in compounds such as salt that resemble in properties the compounds of the alkali metals. It is a protonation and conjugate acid of an ammonia. That's all, and thank you.
Good day, everyone. I'm Elizabeth Portugues from Group 2, Chemistry of Air. So my topic is all about how does air pollutants affect our respiratory system. So first of all, what kind of air pollutants? So air pollutants such as nitrogen oxides, ozone, sulfur dioxide, carbon monoxide, and particulate matter affect different parts of the respiratory tract via a variety of mechanisms resulting in respiratory symptoms. Air quality affects everyone, but some people are more at risk than others. So the airborne pollutants can get past our body's defenses, penetrating deep into our respiratory and circulatory systems and causing damage to our lungs, heart, and brain. So these are some of the symptoms you can get from the airborne pollutants, such as shortness of breath, coughing, wheezing, asthma attacks, and chest pain can all result from this irritation of your airways. Also, lung cancer, heart attacks, strokes, and worst case scenario, early death. These are all dangers associated with exposure to air pollution. So there are many respiratory illness, both acute and chronic, are also exacerbated by air pollution. So what are acute diseases? Acute diseases can range from small irritations to inflammation, allergic reactions, impaired lung function, and full respiratory failure depending on the extent of exposure. And chronic diseases, these are persistent or otherwise long-lasting in its effects, are a disease that comes with time, such as cardiovascular disease, asthma, lung and other malignancies. Oxidative stress caused by air pollution appears to play the role in a number of chronic diseases. So in conclusion, both conventional pollutants and air toxins have been connected to respiratory issues. Once again, I'm Elizabeth Portugues from Group 2. Thank you.
Good day everyone, Stephen F. Orhe, reporting from Group 2. Cause and effect of air pollution. Air pollution solution. The Solar Impulse label is granted to innovative solution to air pollution that meet high standards of sustainability and profitability. Each solution goes through a strict assessment process performed by independent experts. What is air pollution? Causes. It is impossible to describe the whole extent of potential and actual damage caused by all forms of air pollution, but here are the main consequences. Combustion of fossil fuels like coal and oil for electricity and road transport, producing air pollutants like nitrogen and sulfur dioxide. Emission from industries and factories, releasing large amount of carbon monoxide, hydrocarbon, chemicals, and organic compounds into the air. Agricultural activities due to the use of pesticide, insecticide, and fertilizer that emit harmful chemicals. Waste production, mostly because of methane generation in landfills. Air pollution effects. It is impossible to describe the whole extent of potential and actual damage caused by all forms of air pollution, but here are the main consequences.
Air pollution effects. It is impossible to describe the whole extent of potential and actual damage caused by all forms of air pollution, but here are the main consequences. On the environment, air pollution has a major impact on the process of plant evolution by preventing photosynthesis. In many cases, with serious consequences for the purification of the air we breathe. It also contributes to the formation of acid rain, atmospheric precipitation in the form of rain, frost, snow, or fog, which are released during the combustion of fossil fuels, and the transport by contact with water, steam, in the atmosphere. Global warming. On the top of the air pollution is a major contributor to the global warming and climate change. In fact, the abundance of carbon dioxide in the air is one of the causes of the greenhouse effect. Normally, the presence of the greenhouse gases should be beneficial for the planet because they absorb the infrared radiation produced by the surface of the Earth, but the excessive concentration of these gases in the atmosphere is the cause of the recent climate change. On human health, our continual exposure to air pollutants is responsible for the deterioration of human health. Air pollution is indeed a significant risk factor for human health conditions, causing allergy, respiratory, and cardiovascular disease, as well as lung damage. I'm Joaquin Machilaro reporting air pollution effects. Thank you.
Okay, good evening everyone. So I'm Mark Kevin Guiguyen reporting for air pollution control. An example of air pollution control. So these are the pictures. And so what is air pollution control? Air pollution control is the techniques employed to reduce or eliminate the emission into the atmosphere of substances that can harm the environment or human health. So how to prevent air pollution? First, by using equipment or devices, or as an ordinary person, or through the help of other people. But first, we go to the process of how to remove or reduce air pollutants. First is combustion. Combustion is destroying the pollutant. What is conversion? Conversion is chemically changing the pollutant to a less harmful compound. And what is collection? Collection is removing the pollutant from the waste air before its release into the environment and the atmosphere. So let's go to the devices used in air pollution control. So what are air pollution control equipment or devices? Air pollution control devices are a series of devices that work to prevent a variety of different pollutants, both gaseous and solid, from entering the atmosphere, primarily out of industrial smokestacks. First is scrubbers. Scrubbers are air pollution control devices that use liquid to remove particulate matter or gases from an industrial exhaust or flue gas stream. This atomized liquid, typically water, entrains particles and pollutant gases in order to effectively wash them out of the gas flow. An example of scrubbers. And this is how scrubbers work. Next is air filters. Air filters are devices designed to remove solid particulates and molecular contaminants for the purpose of improving air quality in a system or environment. An example of air filters are seen in cars. the cabin filters of car or engine air filter. This is an example of air filter in a structure. Next is electrostatic precipitators. What is electrostatic precipitators? A kind of dust removal equipment in which dust particles are ionized by high voltage electric field and charged by dust particles. This is an example of electrostatic precipitators. Next is the mist collectors. Mist collectors are designed specifically for the removal of mists, vapors from processed air streams for the reduction of air pollution and downstream corrosion. This is an example of mist collectors. And this is how mist collectors work. Next is cyclones. Cyclones are air pollution control devices which, similarly to air filters, separate dry particulate matter from gaseous emissions. This is an example of cyclones. Next is incinerators. What is incinerators? Incinerators are devices which employ combustion methods to break down pollutants into non-toxic byproducts. While these devices can be used to incinerate wastes, solid, liquid, and gaseous form, they are widely employed in a variety of industrial applications to maintain air quality and regulate gas emissions. This is how it works. Next is catalytic reactors. Catalytic reactors, also referred to as selective catalytic reduction, in short SCR systems, are pollution control devices widely used to mitigate nitrogen oxide emissions produced by burning of fossil fuels in industrial applications. This is how catalytic reactors work. Another example of it. Last but not the least, biofilters. Biofilters are air pollution control devices which employ microorganisms such as bacteria and fungi to degrade and remove water-soluble compounds. An example of biofilters is this. So, as a person, I can give you tips on how to control air pollution. First, use public transportation, bike, or walk whenever possible, because we will control air pollution. Second, mulch or compost leaves and yard wastes. Next, look for Energy Star label when buying home or office equipment. Fourth, following gasoline refueling instructions for efficient vapor recovery, being careful not to spill fuel and always tighten your gas cap securely. Consider purchasing portable gasoline containers labeled spill-proof where available. Sixth, keep the car, both and other engines properly tuned. Seventh, be sure your tires are properly inflated. Eighth, use environmental safe paints and cleaning products whenever possible. Ninth, consider using gas logs instead of wood. And last but not the least, and the most important of all, try to conserve energy as much as possible at home, at work, everywhere. Thank you for listening. Once again, Mark Kevin Biguiguin reporting for Air Pollution Control.
Good day, I am Rachel K. Tumaliwan reporting for air pollution. So after the microscale aspect of controlling air pollution, let's proceed to discuss the macro scale of it, wherein it is the air pollution control in terms of the significant contribution of some Philippine government agencies in battling and mitigating the air pollution crisis. First, we have the Department of Environment and Natural Resources. This government agency acts as the lead agency in our country to mitigate air pollution. By how? They formulate policies and standards subject to national laws, prepare a sustainable action plan, coordinate its members, wherein the members include the concerned private sectors, organizations, local government units, and national government agencies. They also submit and publish an annual air quality status report, which is used to devise the Integrated Air Quality Improvement Framework. What do we mean by this air quality improvement? It is the adopted official blueprint with which all the government agencies must comply with to attain and maintain ambient air quality standards. Next, we have the local government units. They help in the country's fight against air pollution by implementing rules and regulations for the good of the locality that they are serving. For example, they prohibit smoking in open and enclosed public places, wherein this action by this LGU could help in controlling one source of air pollution. Next, we also have the Department of Education and the Commission on Higher Education. They help in inculcating the causes, sources, and effects of air pollution in their lectures and seminars. So these two government agencies, which guide the education of the Filipino people, will bring awareness and knowledge from what they have imparted. The Filipinos will be enlightened, leading them to become better and responsible citizens in our country from the habits they once practiced, which little did they know, they were already contributing to the air pollution. Next, we have the Department of Science and Technology. This agency establishes a national research development program to prevent and control air pollution. It usually targets promising young science and mathematics inclined students to bring out their ideas and suggestions through a research paper in fighting against the different issues in our society. Air pollution is one among them. Next, we also have the Philippine Atmospheric, Geophysical, and Astronomical Services Administration. This agency regularly monitors the meteorological factors affecting environmental conditions of Earth, including ozone depletion and greenhouse gases. This is important since the data of monitoring from this agency works together with concerned agencies and local government units to prepare and completely implement a national strategy to reduce greenhouse gas emissions in accordance with the United Nations Framework Convention in the scope of climate change. Moving on, we also have the Department of Energy. This agency improves the fuel composition for greater efficiency and lower emissions by setting specifications for all types of fuel and fuel-related products on the permissible contents of additives. By how? The DOE has authority to limit ingredient or begin the phase-out of additives in making fuel and fuel products, especially if it was greatly foreseen as a threat in our environment. But we should remember that the DOE does not only implement standards out of their personal opinions. The standards are primarily based on the threshold levels of health and research studies. Next, we have the Land Transportation Office and the Department of Transportation and Communications. These agencies offer in their office emission tests for vehicles to determine if it complies with their emission standards. They reserve the right to impose more stringent air emission limitations for automobiles and prohibition on a specific type of a vehicle in a particular areas. Furthermore, the DOTC and LTO oversee the implementation of roadside activities for vehicles to check if some individuals do not comply with the in-use emission standards. A penalty awaits for every violator, like no testing probes, no testing machines, non-appearance of vehicles at testing centers, and falsifying test results. Given that we enumerated things in a macro sense that could help us eliminate and control air pollution, it is still the micro scale that more counts. The current situation of our environment is the effects of human activities. Once again, this is Rachel K. Tumaliwan reporting for air pollution and reminding everyone that we should be responsible inhabitants in planet Earth. Thank you and good night.